Hello, everybody. Can you hear me? Can everybody hear me?
Yes, sir.
Wonderful. Okay, now, as I told the other students, hopefully you did all the parts today regarding the binaries for exercise 1 and 2. So your assignment for Wednesday is to do all of them, all 4, and you will be turning those in on Wednesday, not today, and basically finishing them off, and you'll understand the logic of the binary leading into ternary and whatever else, because it's just a slight modification of the rules. So basically, I hope that you will all understand the nature of what we're trying to do here. And what I'm going to do first is use the board to kind of go over initially the rules that we did for binary, and then move to the slides to go a little further, and then you can see my handwriting a little better. But I think looking at it, I think I'll go to the PowerPoints right now and then get this going with it. Hold on a second.
Dr. Douglas.
Yes, question.
So we turn in all 4 of the binary sheets on Wednesday?
Correct.
I just wanted to make
No, the binary, ternary, and acid names, it's all 3 of them together.
Okay.
And basically it's relatively straightforward, and don't overcomplicate it. What I want to see is everything completed and you all ready to kind of move on. But essentially what we're doing now, and I talked about common names and such like that, chemical nomenclature, but what I'm going to do now is add slides to it. I'm in process of adding additional slides so I can continue the rules. Okay, so I'm going to start sharing the screen now, folks. Can you all see the screen at the other end?
Yes.
Wonderful. Okay, good. Okay, so let's get the slideshow going. All right, now let me go back on the slides just so we can understand. Again, I apologize for the handwriting, but this will kind of illustrate the whole point. And let's do a little quiz regarding the nature of these materials. Okay, what is this subject? Oops. What is this compound? Yeah, oxide. And what is Li? Lithium. Very good. And basically it follows the rules. So it's very straightforward. Essentially, there are all sorts of things regarding it. Okay, how about this one? Aluminum chloride. Okay, just follow the rule. It's very straightforward. Let's go to the next one. What's that? Huh? Sulfur dioxide. Very good. How about this one? Sulfur Tri-Oxide. Wonderful. Okay. And then you can come up with the different ones. Okay. And we'll talk about those in a minute. The transition metals. There's another way to do these. And let's look at this first. And remember the rule that oxygen is always -2. Oxygen is -2. So what is that? Very good. Vanadium 5 oxide, or in some contexts, vanadium pentoxide, because there are 5 there. But the key thing is it's vanadium 5. That's correct. If you remember the vanadium pentoxide, it works very well. Okay, is everybody following the logic? Okay. Now, common names, uranium hexafluoride. There's one that one person asked about regarding this ion. This is called hydroxide. Okay, Cn minus is cyanide. And unfortunately, you just have to learn those. And there's a chart for that. But it's like learning 5 or 6 of them. It's not giving this page and saying, learn this page with no explanation why, okay? And unfortunately, a lot of high school teachers like to do that. And I have no idea why, because it's like there's a logic behind it. I have a hunch I didn't have much chemistry in college. But the point is, again, there's a bunch of rules that go in fitting these that have to do with this, and you just got to learn them. Like SCN minus is thiocyanate. And unfortunately, those are just rules that have to go on. Now, yes.
On a test, are you gonna like give us a sheet that has like?
No, on a test, I'm not going to give you the more complicated ones. You'll just learn them in your things.
Where are they at first like study?
Well, there's a chart in your book, Common Ions. There's a chart in all of them. And as you practice, particularly these exercises, they'll be there. Okay, so that's the point is as you practice, you'll learn it, and then you can just look it up or something. So I don't like to give tricky questions on the exams to come up with something archaic that kind of violates what I'm trying to teach you. I don't believe in frustrating students, okay? My job is not to play gotcha with students, particularly biology majors, because unfortunately biology, you learn it differently. And chemistry, you're asked to learn that because it's more thinking critically and conceptually. Whereas I taught biology once in high school. I had a great time doing it, but I taught it in a systematic, more conceptual approach. And the high school students liked it, but I didn't like the memorization that goes with traditional ways. But that's just the way I look at it. But I like biology, I always have, but I decided not to be one. Now, the next topic is what's called ternary compounds. And this involves a metal, a non-metal, and can anyone guess the next part? Based on what you already saw with sheets 1 and 2, the ones you didn't know. What else is involved in those? Someone asked me about them and I said, don't worry. Plus oxygen, okay? And it's very straightforward. The first one is a metal, non-metal, and it's the natural version. In other words, it's what they dig out of the ground. A lot of oxides can be dug right out of the ground in pure form. It's quite amazing. Calcium sulfate is called gypsum. There are huge stockpiles of gypsum all over the world, okay? Sodium chloride, salt, there's huge stockpiles of salt all over the world. Sulfur, that's just mined. They dug it out of the ground, it's almost pure. For example, the Great Salt Lake in Utah, the salt there is mined by Morton Salt to make the stuff you get at the grocery store eventually after refining. But the metal, non-metal, and the natural portion, so you start with the name of the first one, you then have the other name, and then the ending. And I'm going to go into that now by using this example. In the other rules, what is that compound? This is a binary. What is it? Sodium sulfide. Very good. Now, you put one more on. What is this one? ATE. So the I gets switched to ATE. Okay? It's that simple. Now, let me show you one you haven't seen. What is that? Chlorate. Very good. Wonderful. Okay. What's that? Huh? That's an N. Potassium nitrate. Yes, wonderful. Okay, now you've seen the sheets with all these different ions in there. What does it mean when it says 8 on the end? It's an ion with oxygen. So what is this ion called? Sulfate. Okay? It's not sulfur tetroxide, it's sulfate. because it has this little charge on it. It's connected with this sodium sulfate compound, okay? So essentially the ending has that associated with it. So a metal, non-metal with an 8, and this is the normal form. Now I'll describe in the next rule what normal means in a minute. Basically, it's the stuff that comes right out of the ground. It's a naturally occurring form that has not been modified by chemical means in the laboratory or some other method, okay? So basically, that's the word. Now, those of you listening at a distance, Katie, Emily, or Riley, do you have any questions? Do you understand also? Can someone speak up?
I don't have any questions.
I
Does
don't
it make
either.
sense?
Yes, sir.
Oh, wonderful.
I have a question.
Makes sense to
actually.
me.
Sure, go ahead.
Does the oxygen matter what charge is on it, or is it no matter what ATE?
Well, usually it's the oxygen is always -2, so it's ATE in the natural form. You're thinking ahead. I'll go to the next one, and that's the second rule, which I'll get to in a moment.
Okay,
But
thank you.
basically, the key thing is to understand the logic behind it, and then you'll understand the silly sheet with all sorts of ions. Okay. Now let's go to the next one.
Dr. Douglas.
Yes.
So back when with sulfate, so ternary compounds, the natural form is a metal and a non-metal with oxygen, but
Yes.
sulfate is just sulfur with oxygen. Like there's no metal
Well, it's an
ion.
ion. If it's just sulfate alone, it's an ion. If you go back to the previous ones, I put some sulfur ones here. What are those compounds? Whoever asked me that question.
Binary.
Yeah, but what are they? The sulfur ones on the left.
Sulfur oxide.
Yeah, but what's the rule? This is sulfur dioxide. This one is sulfur trioxide, right?
Yeah.
Okay, but what is this? Sorry, what is this? Going back forward. This is sulfate. Okay, so
Yeah.
because of the later ones, okay? This is sulfate, okay? You understand that?
Yep.
Good, okay, so now let's go to the next one. The next one is the metal, non-metal, and one less oxygen. Okay? So, by the previous rule, what is this compound? Sodium sulfate. Okay, so let's take one oxygen away. So essentially you have this name, NAM, and ending. This is ITE. So what is that compound? Sodium sulfite. Very good. Did we get lost here? Am I still sharing the screen? Can you hear me now?
I can hear you, but you're not showing the screen.
Okay, I'll go back. I don't know what happened. Okay, can you see the screen again now? Okay, very good. Okay, so now we'll put one more here. Oops. Okay, what is that compound by the previous one? By number one, rule number one. RB is rubidium, so what is it? Rubidium nitrate. Okay, how about this one? RbNO2. Rubidium nitrate, yes.
How do you know, like on a test, if you put RB and O2, how do we know that one's taken away? That's not shown.
Practice. You learn the nitrates first with the first rule, and that's why I'm giving you the sheets. Then you'll understand that it's lost one, and then let's go.
So like oxygen should always be 4, but if it's 3 to 1, that means it's
Yeah, usually. Or it could be always 3. Like in the case of nitrate, it's always 3, but nitrite is 1 less. Okay, and for example, what is that? Trite. Yes, because the other one's nitrate. This one's nitrate. Okay, and what I'd like you to do in a little assignment, if you got hot dogs at home, if you look at the thing of hot dogs or sausage, it says sodium nitrite on it. That's what sodium nitrite is. It basically makes it a little pink, the meat. Okay, so there is a little bit of stuff in there, but 1 less oxygen essentially is ite. Okay, yes. It's 8. I just showed the transition. This is 8. This one is ite. Okay. Practice. Okay, so essentially you start with the first one and look at the different ones related, and it's just by doing the homework and doing these worksheets. That's part of why I gave you those worksheets. Once you get the hang of it, then you can look at the back and the front and other stuff like that and kind of fit it all together, and then you kind of get it and the logic makes sense. Okay? No, it could be 3, because sometimes 4 is something else, and we'll get to that. But sulfate is always SO4 minus 2. Okay?
So Dr. Douglas, if it's
Yeah.
O2, then it's ite.
Yeah, if it's 1 less oxygen, it's ite. It goes from 8 to ite.
Okay.
Did that answer your question?
Yes, sir.
Okay, good. Okay, so the third rule, 2 less oxygens. And I'm just going to give one example here. Sorry. Okay, this is by the previous rule. What is that going to be? Potassium chlorate. Yes, good. Okay, this goes to KClO2. What's that? Potassium chlorite. KClO, that's the next rule, name, and then hypoite. Okay, so essentially you have a name here, but then hypoite. So what is that compound called? Yes, potassium hypochlorite. Now, if you look at the side of a bleach container at home or something, or in your dorm if you have any bleach, what is that compound called? Okay, Brandon, you're getting called on. What is it, Brandon?
Well, I'm sorry, what?
What is the last compound called? I'm calling on you. You're the guinea pig for the virtual people.
So the last one would be sodium chlorohypoite.
No, follow the rule. Hypo is a prefix, so what is it? Hypo, name, ite.
Okay, so hyposodium chlorite.
Sodium hypochlorite. See it?
Okay, yeah.
Okay, because if I add one more to it, what is that?
Sodium chlorite.
Yes, and put one more on it. What is that?
Sodium chlorate.
Yes, very good. Now the fourth rule is add 1 oxygen. Okay, so this is sodium chlorate. What is this? ClO4. Well, here you're a prefix that is per-8. So what is that? Yes, sodium perchlorate. H2O2, what's that? Yes, very good. Hydrogen peroxide. See? Now you understand where the per comes from. What does that mean? one extra oxygen. So there's the whole series of them all together. Okay, you virtually, do you understand the logic?
Can you repeat the fourth rule? The Wi-Fi just went out.
Oh, okay, all right. I'll hold on a sec. I got to add a slide. So let me go add a slide here. I'm going to add a slide just a moment. Make it bigger. Oops. Okay, I'm going back to share the screen again, folks. Okay, we're back to the previous one. Okay, this is the previous one. I'll make the 4 bigger so you can see it better again. Put the printer back on here. 4, 1 extra oxygen. Okay, so essentially if you have like this, what is that compound called by the previous rule? Yeah, lithium bromate. What's that? Lithium perbromate. What's that? This fits number 4. This is 1 extra. So this is potassium permanganate. Okay, so the manganate in there, even though I haven't shown you before, what is this one? O3, like that. What's that one? The one on the left. Manganate, yes, and then it goes to potassium permanganate. That's a very common thing you'll use in the laboratory. Okay? Did that answer your question, the person that asked virtually?
Yes, thank you.
Wonderful. Okay, so basically, these are the main rules regarding the nature of things. And I've got one more. I've got one more slide to make here. Let me go back out again. Hold on a sec here. One more slide, and it has to do with acid names, and it just adds one more set of rules here, which is relatively straightforward, so we could do that again too. So let me go back to get you back on the shared screen again. Okay, the last one is, oops. Yeah, I'm going to talk about that in a minute. It just adds one extra part to it. That's what I'm doing now. The logic will make sense because basically it's just putting together everything you've learned. We're learning how to walk here through this, okay? So let's just start with one very basic thing first. I want to show you this KClO3, KClO4, KClO2, KClO, and then KCl, okay? When this is transferred to the acid, this is HClO4 aqueous, HClO3 aqueous, HClO2 aqueous. The aqueous has to be there for it to be an acid, okay? And then this is HClO aqueous, and then HCl aqueous, okay? So there's a whole bunch in this. So let's go back up the thing. Based on what you learned before, what is the one here, this number 1? What is that one, the name? Potassium chloride. Okay, now let's go to this one, number 2. What's that? Potassium chlorate. Okay, number 3, potassium chlorite. Number 4, potassium hypochlorite. Okay, number 5, potassium perchlorate. Very good. Okay, when you go to acid names, essentially what happens is you put the acid at the end, and this becomes perchloric acid. Okay? Do you see the logic there? It goes from being potassium perchlorate to perchloric acid. What is this one then? Follow the logic, please. This one here, what is that one? Brandon, I'm going to pick on you again. What's the next one?
That's gonna be
You got the
potassium
perchloric
chlorate.
before, so what's the next one, just down from that?
Potassium chlorate acid.
No, this one is perchloric acid, right? Here is perchloric acid. What's this one here? Well, this will just be chloric acid. Okay, what did I change?
You took away the prefix.
Yeah, you took away the per, okay? Now, the next one is called Chlorus acid. What does ick to us mean? Well, the ick to us means essentially ick is the higher one, us is the lower one. Okay, so essentially you have the ick to us there, and I'll make another slide in a minute just so you can see the transition. So essentially you got the Chlorus acid, and then this one is hypochlorous acid. Okay, and then here, this is hydrochloric acid. Because it's a binary. And basically the hydrochloric acid means it's in water solution. So it's got the hydrogen in there, but it's listed differently. And you'll get the thing of that also, okay? So does that logic make sense to everybody? Paige and Katie, does that make sense to everybody?
Yes.
Kind of.
Pardon my handwriting, but I'll go to the slides in a moment, okay? You can understand the handwriting. You can understand the slides better than me. I'm just adding these extra things to it. So basically, yeah, I'm gonna make a new slide and duplicate it, okay? I'm just gonna put them in separately so you can see them better. So just bear with me.
Dr. Douglas.
Yes.
So it's only an acid if it has the AQ next to it.
Yes, it's only an acid. If say example you had this, oops. Say for example you had this HCl. What is that called without the AQ? Hydrogen chloride, because it's a gas. Okay, in acid form it is AQ like that. It's hydrochloric acid. Okay, if you have HClO4, this is called perchloric acid. Only if you have the AQ associated with that. Yes. Well, then you say it's hydrogen chloric or hydrogen. That's hydrogen fluoride. Yeah, but if some of the later ones in 3 and 4 have AQ next to it. And you'll see those there. Okay, it has to have the AQ to be an acid. AQ means acid. That means it's in water solution, okay? So basically here, we can go through the rules. I'll just put the rules again like this, HClO4. I'm sorry, everybody, it died again. Can you hear me?
Yes.
sir.
Hear me?
Yes, sir.
Okay, good. Okay, so HClO. Sorry, got to go back to this pointer. Okay, HClO3 is going to be what? Aqueous. Aqueous. What is HClO3? Perchloric, then this is chloric acid. HClO2, aqueous. Chlorus acid, yes, very good. Because you got to have one that's lower. Okay, HClO like that. HClO, that's hypochlorous, hypochlorous. Now, that's true for all of them. What is this acid called? And be logical, it fits these rules. HNO3AQ. Very good, nitric acid, wonderful.
So it's always going to start with H. Does it always start with H?
Yeah, because it's an acid. Acids are defined as something that gives off hydrogen ions.
But you don't necessarily say like hydrochloric.
Hydrochloric acid is only with the binary ones, hydrobromic, hydrochloric, whatever, but when it's the ternary ones involving that, it's nitric acid. It follows these rules. Like this next one is sulfuric acid, okay? How about this one? Brandon, I'm gonna pick on you again. What's that one?
That's sulf.
No, the one at the top I just underlined, at the top right. H3PO4, what's that one?
Phosphoric acid.
Yeah, it's very good, wonderful. Okay? So, instead of memorizing a chart, follow the rules, okay? Does that fit? Now, you can finish the worksheets. 1 through 4, fill in the blocks of 1 and 2, and then finish them off, and you'll get the hang of it. And again, it's just practicing. And you'll know acid names or whatever else, and you'll be very prepared for the exam, okay? And I promise I will not do tricky questions on the exam. The exam will be a week from Thursday. I know you, how many have exams in this week in other classes? Probably a lot of people. That's why I'm rating, okay? So essentially we'll do that. What I'm doing today is essentially going over that, and then I'll go over the slides now and move to the slides to show that. But I'm done with my horrible handwriting. Yes.
So the H2SO4 you're involved with that.
Yes, and what would this acid be? Just so you understand this, H2SO3 aqueous. Sorry, H2SO3 aqueous. What's that? If you have sulfuric acid for the first one, H2SO3 aqueous is sulfurous acid. So it goes ic to us there. And you can have nitrous acid also. So there's ic and us for the lower one. Okay? Any questions before I finish off the chapter, the chapter slides? The stuff on the chapter slides, I'm going to go relatively quickly through it because it's a matter of putting the pieces together what you've already, and repeating what I did. But the way the textbooks are, they don't give my method for doing it. I just happen to like mine. Hein comes the closest to it, but unfortunately he takes shortcuts. That's kind of annoying for me. Okay, so let's go to the next slide here. Ionic compounds, a metal and a non-metal. The anion, you add I to the element name. That's exactly what I said before, right? Okay, and so let me go back. What is that compound? Barium chloride, very good. Okay, what's that? Potassium oxide, wonderful. What's that? Based on what I told you, the OH is hydroxide. OH minus is hydroxide, and that's just one you have to learn, but it kind of fits with the others also. What is it? Very good, okay? And then that one, Potassium nitrate, yeah, that's a new rule. But unfortunately, the slide doesn't give the second rule then. It says add I to the element name. When you add oxygen, it adds that thing. So this is plus oxygen is the 8. Then you can have ite. What's KNO2? Potassium nitrite. Yes, wonderful. Okay, what is this? What is this? Okay, what is that compound? Hydrogen iodide. Yeah, what is this one? Hydrogen
Hydrogen hypoiodite.
Yes, hydrogen hypoiodite. Okay, what's this one? This is an older one that I learned in college that I thought was funny, but only because I like to watch a certain TV program.
Hypoiodous acid.
No, that's hyosilver.
Oh, the AG.
That's from the Lone Ranger. I grew up watching the Lone Ranger. Okay, so in case hyosilver. That's a chemistry joke. Okay, and it helped me to learn the rules there. Okay, so basically they're that. With the transition metal ionic compounds, you have the charge on the metal with Roman numerals. Okay, so this is what? Iron what? Iron 2 chloride. So you have 2 of them. So it's iron 2 chloride. It's also called ferrous chloride. This is what I learned when I was in college. And I used to teach this more, but unfortunately it's never used anymore. But it's very useful for understanding the nature of the is and the ick if you start at an earlier stage. Okay, what is this next compound there called? The one right below it. Iron, this one, the top one is iron 2 chloride. What's the second one? Iron 3 chloride. Okay, so you have iron 3 chloride there. Okay, and then essentially it's also called ferric chloride. Okay, now what is that compound there? Chromium sulfide, but sulfur is -2. If you look on a periodic table, it's right below oxygen, so it's -2. So if you have 3 -2s, what is that? -6. And 2 chromiums have to be even off, so those are +3 each. So that will be chromium +3. Okay, so that'll be chromium 3 sulfide. Okay, now let me go to this again and add a slide here. Okay, okay. Now what is this one? This one here. Oops. What's that?
Iron oxide.
Iron 2 oxide. Very good. Okay, what is this one? What is that one?
Iron 8 oxide.
Nope, that's a Ferris wheel. That's another chemistry joke. Okay. Okay, now I'm going to delete this and go into another one. Now, you may think they're stupid, but they'll help you to remember it, okay? All right, so what is this one here? Oh, never mind. I gave enough of that. That's fine. Okay, so let's go to the next thing here. The ide refers to where they are in the periodic table here. This is the chart. Often your book just uses a chart without giving the rules. It's kind of annoying, but basically they're there. And then here, this is often a table that's used and said, learn this. Okay, so basically it kind of goes then, but again, they follow the rules there. Molecular compounds, whether you have a metalloids associated with that, you have common names associated with that, essentially, and you could have mono, di, tri, etc., which I've already talked about. And then with there, hydrogen iodide, nitrogen trifluoride. What's that? Sulfur dioxide. Okay, what's that? Dinitrogen what? Yeah, dinitrogen tetrachloride. Okay, and then nitrogen dioxide. Dinitrogen monoxide, this is also called, and you have heard of this, oops. This is also called nitrous oxide or laughing gas, okay? So nitrous oxide is laughing gas. It's a clear colorless thing that'll put you to sleep if you're getting a tooth out or something, if you ever use that. And then there's a chart they give for naming them that kind of helps some people. If you want to use that naming chart, feel free to do that. Acid names here, when they're dissolved in water, the pure substance is hydrochloric there, then it becomes hydrochloric acid. So you add the ic and add the acid to the name. Okay, and then there's a bunch of things regarding that. And again, I like using the rules. Okay, oxoacids, nitric acid, carbonic acid, phosphoric acid, and then naming them, essentially you have those associated with this. Oxyanions, you have 8 associated with that, and essentially there. So phosphate, etc. Those follow the rules as before. And then a couple examples there with the different acids and the things that I showed you before. And then bases have the hydroxide at the end. And then hydrates just have a water molecule, dihydrate, monohydrate, and heptahydrate. And that is what the lab is going to be on this week, is on hydrates. So you'll understand the nature of hydrates is they get added at the end and it gets put into the additional as hydrate. Okay, and then common systematic names associated with this, organic ones, and basically that kind of has its own nomenclature that is logical and fits regarding those. Okay. So essentially that's the end of that slide set. Now, this essentially is the end of this lecture. I'll continue, finish off chapter 2 with other material in it, and then introduce you to the next topic on Wednesday, and we'll have the quiz on chapter 2 on Thursday. For those of you who are attending virtually, I will send out an email seeing if we can all meet at 11 o'clock in this room and take the quiz. You'll get 20 minutes for the quiz, just like they were at the end of class. Any questions for those of you who are distance?
No.
Very good. All right. Well, thank you very much. I'll see you all folks or whatever on Wednesday.